Hello, and thank you for joining me. You're here with data science teacher Brandon, and we're going to discuss the ElasticNet model with sklearn. So this is a model that combines the regularization techniques of the L1 and the L2, the lasso and the ridge. Okay, to kind of get the best of both worlds, and finding the right balance between them is the tricky part here, right? It's not just that both of them together work well, it's finding for your data set the balance that works well. Okay, so this is really a much more advanced version of the linear regression with a whole bunch of extra math put on top of it, but trying to deal with the limitations of the linear regression. Okay? So what I'm going to do, I started with making my own regressions a bit easier here, adding complexity in terms of the amount of features 40, and then I made it so that 35 are informative. So there's five that are just kind of a whole bunch of noise. I turn up the noise a lot to make it as hard for my model as possible. Train test split here after make the x and y, and then just standardize. And just so we don't get any of the effects of the scale of each of the variables on our model. Okay. So here we're getting the ElasticNet. I'm putting the alpha, just setting it as to start with a 0.5. So that's the strength of the combined L1 ratio. So the L1 ratio is what percentage is L1 and what percentage is L2. So L1 being lasso, L2 being ridge, and then the 50% is what is the combined strength overall. Okay. So again, there's a little bit to play around with right there, the alpha and the L1 ratio. I find truly my experience has been that a really high L1 ratio doesn't really do very good. A little bit of it really helps kind of get rid of the unimportant features, but doing that too much ends up getting rid of valuable features. Okay? So if I just put it like that, just trying the two kind of defaults, 0.5, 0.5, I get a 95 and a 95 score. Okay, so we could do a grid search here. That'd be a little bit more interesting to understand what the impact of both of these, the balance of them. So what I did was I made a linspace. I made a list of the thresholds, so 0 to 1. You technically can do more than 1 if you wanted to, but I've never really had a lot of luck with that, making that work. But here, so just going up to 0 to 1, and this will be the threshold for both of them, and we'll end up we'll iterate through the alpha and then the L1 range. So what we're going to do here, just a simple loop. I'm going to, for each time I go through this loop, I'm going to go through the alpha threshold, and we'll go through it again, right? So the first time it's going to be the alpha, second time it's going to be the L1 range. Okay? I'm going to save the train and test scores in two separate lists that I'm going to put into data frames here that I can make eventually a nice little correlation matrix out of. Okay, so I'm going to go through, iterate through one, then I'm going to make some, or initialize some blank lists, and then we're going to make another threshold. So it's going to go in one, and then we're going to stick it together horizontally. Okay, so this is going to go basically going to make one column to get started. Each one of these I'm going to stick together horizontally. Okay, so what we'll do is we're going to go iterate through, we're going to create our ElasticNet with our alpha and our L1 that we're iterating through. We're going to train it. We're going to get the score. We're going to append the score. We're going to get the score of the test. We're going to append that. And then, so we're going to iterate through that's going to be the whole list for one of these. So we'll have one dimension of data, one column of data, and then we're going to join that one column of data to our data frame on the X or so along the x-axis, the horizontal axis. Okay? I'm then going to set the column names and the index to the threshold. A nice little thing. And so this shows us a good balance of really, it is really a give and take relationship. You can see here that with the L1 ratio turned to 0, it didn't do quite as well. So it did, getting rid of some of the unimportant features. So there was 5 that were not needed. So getting rid of those to some extent is helpful. And then the alpha here going all the way up to 1. So the strength, you too strong, it's not good, right? So really, I think the thing here is that some sort of balance seems to be the best. I think this would be in the range when you're looking at the train, a little bit of overfitting. My personal experience is, and this was on the randomly generated data set, which I have found actually have a lot of complexity to them. I really have found that alpha turned up all the way to 1 is not uh, truthfully very favorable. And see alpha turned down to 0. It actually does really good with the alpha turns out. So really, this is kind of saying that less alpha is a little bit better. But looking at it on the test shows a similar pattern, slightly lower scores, but that's what we expected. I wondered if we were seeing this pattern because it was on a generated data set and not a real data set. So I imported the wine quality data set here. I'm going to just predict it on a regression basis as well, making the features X, Y right here, doing the same thing that I just did up above, going through the loop, creating the alpha for X, Y, getting the scores. I go through this, and then putting that one column of data into my data frame. Okay, going through that, and then going through that again. Okay, and so we see here, putting that into heat map, we get a very similar pattern here, right? So it seems that L1 ratio turned up to the maximum seems to be a little bit better, right? So we're putting that, and then alpha being a little bit lower, not having full strength. I think that's a good thing as well. My personal experience has been that the L1 ratio is somewhere more towards the middle. Seems better. This is not showing it in these examples here. And they could be just because they are technically still quite simple data sets. The wine data set that we use for this one is a beginner data set. That could be the reason. I would say in my word, word of caution to try, the max L1 ratio, I would say that works just the lasso regression does not work very well by itself because although there are unimportant features, they're still used a little bit and they still add a little bit of value, um, especially in things like random forest or something like that. So if we want to compete with something like random forest, we need to make sure that we're saving a little bit of this. So I really find a good balance of alpha and a good balance of L1 ratio are really going to be favorable for your overall training. You can see the test scores did quite similar. Again, this is saying that L1 ratio is favoring the L1 ratio. So the lasso regression, I would say I haven't always noticed that. I would say it really is though about finding the lasso. So now with this loop, you'd be able to find what works well on your data set. So have fun trying it out, conducting your own experiment. I will see you in the next video.